All right, guys, and we're back. So let's continue on our discussion. So a couple of things. One, you'll notice that there's in the lecture slides folder for the class materials for this course, there's another set of slides called additional testing. So that is a more extended discussion on testing and what software testing looks like. And beyond software testing, it's a systems testing as well. So that's a set of slides from software engineering course that I've taught before. You can also look at that to have a more deeper understanding of testing. Much of that, beyond what we talk about in this class, will not be covered as part of this course. So like the more finer points of testing will not be covered, but there are things that I do want you to understand. For example, one thing that I definitely want to make sure to say is testing cannot be used to show that a system works. Okay. Now that may sound kind of counterintuitive. It's like, well, if we can't show that a system works, then why would we do it? Like that doesn't make any sense. Okay. The problem is that for a system, for example, in fact, let me just go ahead and share this. Let me go ahead and share the example that we're going to work through here in a moment. Okay. Here you have, I've written up the kind of the skeleton code for a bank account class. Okay, so we're going to have a bank account. Now, obviously, in a real system, you would have a bank that would have, some type of array list or array of all of its bank accounts and something like that. But this is just the bank account class itself, and we're just going to test. We're going to work through how to deposit money into the bank account, how to withdraw money from the bank account, stuff like that. Okay. Now, here's my question. I want to test the deposit method. Okay. How many different possible inputs can I give to the deposit method? What do you think? How many different possible inputs can I give to the deposit method? Okay, 4. What are they? 1, 2, 3, 4. I can't deposit 5. Now, not types, I mean values. Like how many different values can I give? Because amount is a numeric type, right? Okay. Actually, yeah. Well, not quite infinite, Furkan. Not quite. Although you're close, right? However, how many bits is a double? The 32-bit number. So 2 to the 32 different possible inputs. All right. Because I can put negative. I can put in 1. I can put in 2. I can put in 3. I can put up 100. I can put in 200. I can put in. Are you kind of getting the idea here? All right. That there's a lot of possible inputs, right? And are we expected to test all of them? Okay. Hopefully, you guys are saying, no, we can't test every possible input to the system. But the only way to make absolutely certain that a system works would be we'd have to test every possible input to the system. And we would have to make sure that every input maps correctly to its expected output. So as I'm hoping have figured out in this is it would be impossible to prove that a system works. Then why do we do testing? Why on earth would we do something if we cannot prove that a system works? And this is why programmers don't like testers. My job as a tester, my job is what we would call, what you would call a quality assurance engineer. Okay. My job was not to prove that the code works. My job was to find places that it did not work and report those to the programmers so that they could fix them. So you can imagine, I was not the programmer's favorite person. They did not like me. Why? Because every time that an email came to them, or every time that a report in the bug system happened with my name on it, what did it mean for the programmer? It meant I had found something that did not work. And there was something that they needed to fix. All right. But I was doing my job because, and this is for those of you who, when you get into your software engineering and your software process courses that will come later, you will find out that problems, if they are found sooner rather than later, are much nicer. Much nicer if we find them sooner rather than later. Okay. So if you look into that extended discussion on testing, there will be a discussion about unit testing and integration testing and system testing. So a unit test would be something like this, where we're going to test a specific method. Yeah. Or maybe a unit test might be we're going to test a specific class, although that's even actually a form of integration testing. Right? And then we're going to test this class. So this actually needs to be public class. Okay. This class, when we incorporate it as part of a bank program, that's integration testing. We're going to put them together. Okay. Then after we're done with our integration testing, we'll do system level testing. And then once we're done with system level testing, we'll do what's called production level testing. And that's where we actually put the system out there and test it on there when it's out in production, when it's out where users can get a hold of it. And then it's released. At that point, any errors that are found by the users. And that's something that we do not want to have happen. The most costly errors are ones that are found by the user. For the most part, anytime that you've ever had a patch, like if you've ever been working on your computer and suddenly this little notification comes up and says, oh, it needs to shut down and it needs to restart because there's a new patch that needs to be pushed to your computer. Most likely that's a result of errors that were found after the program was released. Okay. And those can be costly. Do you like when that notification comes? I don't. Do you like when you're working and suddenly a pop-up comes up and says your computer will shut down in 60 seconds, please save all your work? I don't like it when that happens, right? But that comes because there was some error found or some weakness that was found in the code after it was already sent to me. Right? So those are the most costly ones. Had that error been found or had that problem been discovered before they released the code, they could have fixed it before they released the code, and then I wouldn't have to shut down my computer when I'm in the middle of work. All right. So we want to make sure that we write good tests, good thorough tests that we can use. right, that we can use to be able to have a good idea that all the errors that are likely to occur have been found. That's what we're trying to do. We're trying to find errors before they get to the user, find errors and fix them before they get out to a user or to a customer. Okay, and if we write good tests, then we will make sure that we have a good confidence that we have found the errors, or that the errors that we're looking for don't exist. Okay. All right. Okay, so let's talk about bank account here. Let's talk about this, and we'll talk through some things such as code coverage and stuff like that here in this example. All right. So how do we do this? So we have a bank account. These are the only methods that we're going to worry about for now. All right. What let's see. Where should we start? What do you think? Okay, we have a constructor. Yeah. So I've already written a constructor here. Basically, the way that I've defined this is we give it an account number and a type. So a type would be like a personal account, a business account, something like that. And when we open our bank account, we start out with a 0 balance. Okay. So do you want to write a different constructor, Arjun? Okay, so that's probably okay then. All right. What should we do? Well, first of all, this isn't going to compile, is it? All right. If I try to compile this, I'll get an error. All right. Ah, yeah. That's a good one. That's a good idea, Rajat. So return balance. Okay, good. So we compiled. All right. Well, let's start testing. So I created my test account, my bank account test. Okay, we have this default test that always fails. We'll get rid of that. Actually, public void. We'll call it test case 000. All right. So we want to make sure that we can create a bank account object, right? Account number 1234, type personal, and that's all we need, right? So how will we test that this this bank account was created? How do we know for sure that this bank account was created? I'll see. Yeah, okay, you could do that. Actually, one thing I forgot, I think, yeah, I forgot. Okay. We should go ahead and also have our get methods for the others as well, right? Now notice just for this example, I'm not going to have a set method for these things because I don't want to change the account number or the type once it's created. Okay. Now one thing we could do is we could say, okay, all right. So this should pass, right? We're saying we want to make sure, I think it should be assert dot assert equals. All right. Oh, wait. It's not a variable, it's a method. Okay. So this is very common. What we want to do is when we test a constructor, we want to make sure that the parameters were set correctly. So if we run this, we should get good, a passed test. That's good. And the thing is, we can do this with all of them. We can do this with all of our parameters, right? All right. And we can also check sort equals 0 for the balance. So here we're making sure that the account number is initialized correctly, that the type is initialized correctly, and that the balance is initialized correctly. Okay, and this, by the way, this it's not an error. It is a warning here, right? I'm gonna explain what that is in just a moment, because it's this one here that's giving me that. It's this test case 2 that's giving me that. If I were to comment that out and try to compile it, I would not get that warning anymore. Okay, but we'll see why in just a moment. I don't want to get into it just now. Okay. So I can run this. Oh, we had a failed test case. It's about this floating point numbers. Why did that fail? What? This is 0, right? The balance is 0, isn't it? What do you think? Why do you think this is a problem? Why do you think this failed? By the way, that's the reason that the warning was given up here. Where are you? Right here, this warning. Well, is this okay? So what if I did that? And it still failed. Notice this, it's telling me this expected actual delta. Do you remember we talked about, if I go back here and let me show you this in the example. Okay. You remember that? We talked about this last semester. That should not be 0.999999, should it? What should it be? If I was adding 0.1 to sum, 0.1 plus 0.1 plus 0.1, it should be 1, right? But why does it display as 0.999999999? Lots of nines. Do you remember why it does this? Right, because it's the double type, it's the floating point type. And the way that floating point numbers are stored is they aren't always exact. And so for this reason, right, so if we were to step through this code line by line and take a look at what the value of sum is. Sum is 0, sum is 0.1, good. Sum is 0.2, good. Wait, what just happened? That's not right. That is not right. Okay, now we're back on. Okay, now that's right. Now we're back. Okay, that's good. 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 But hey, wait a second. What happened there? What? So here's my question. If I were to ask you, is that 1? What would you say? Is that practically 1? What would you say? Yeah, it's practically 1. If I were to ask the computer, is that 1.0? What will the computer say? Right, exactly. Because this is not exactly 1.0, right? Therefore, I get out of here. I go back to the test one over here. I cannot compare a double to another double, right? To say for exact equality. So what it's suggesting that I do, one of the things it's suggesting that I do is use what's called a delta. So if I do this, okay, now we passed. Good. And basically what it's saying is that are these the same to within these 6 decimal places? So if I were to say, okay, this should fail. I think it should fail. No. One more. Let's take one off. This should fail. Right. So this failed because to within this many decimal places, this and this are not the same value. But if I were to add a few more zeros, to within this many decimal places, this and this now are the same value. Okay. And this is a much easier way to do this than the way it used to be. The way we used to do this was we used to use this thing called epsilon and set a value and have this absolute value of this. It was very difficult. But basically what we're saying is I want to compare this. Does it practically equal this to within some small value, to within so many decimal places, right? And you can set this as many or as few as you want. Because if I were to say that, this would give me a passed test case. Because within one decimal place, 0.05 and 0 are the same. But for banking, that's not good. We don't want that many. We don't want that few decimal places. But you know, 6 decimal places, I think we're okay, right? All right. So this is how we compare double values, because it's not, or double or floats, because it's not exact. Okay. All right. So now we've tested our constructors. We've put it in there correctly, right? Now we want to test, let's test our deposit method. Let's do, okay, we're going to test 101. We'll give it a special name, deposit test. So we'll create a new bank account. We will deposit, how much? 100? Does 100 sound good to you? 100 sounds good to me. So how much should our balance be after we deposit 100? Yes. Okay, good. All right. Compile it. Good. Okay, so it compiles and we run it and I get a failed test case. Well, but I deposited 100. Why didn't I get, where's my money? Why did the bank steal my money? The bank stole my money. The bank stole my, this. I'm not banking with this bank anymore. I'm gonna go get another bank. What's going on? Why did this test case fail? So I'm the tester. I sent this back to the programmers. What's your first thing you're going to do as a programmer? What are you going to do? Well, yeah, balance is, but how I deposited? I called the deposit and I didn't get any kind of error. Yeah, right. What does the deposit method do? The deposit method doesn't do anything, does it? Psh. We are so silly. We're so silly. Okay, so what should we do for the deposit here? What should our deposit method look like? Ah, good. I like that answer. That's a good, simple answer. Okay. So we compile this. Come back over here. We compile this. We run this. Yay! Sorry. We're excited. Hold on. I used this in one of my other classes the other day. So yay. So we have a pass test case. Yeah. So we're gonna dance. We're gonna celebrate. Right. All right. So we're done, right? Our bank account's all completed, right? Bank account's completed. Everything's ready. We can ship this off to the customer, right? Arjun, why not? What are we missing? Oh, we need to withdraw money. All right. How do we withdraw money? Oh, Furkan, you're thinking ahead too. What about if the deposit's negative? Somebody deleted a comment. What should we do first? Should we withdraw? Should we check? Okay. Let's do yours, Rajat, because I'm going to also talk about the what happens if the deposit's negative afterwards. Okay, so balance, oh, not caps lock, balance minus equals amount. Okay. And so we can do our withdrawal test. So we want to did I call it withdrawal or withdraw? Okay. Withdraw 100. Let's actually hold on. Let's do something first. Let's do. We don't want to withdraw from an account that we don't have any money in. So we want to deposit 100, and then we will withdraw 10. So what does that mean? How much should we have after we deposit 100 and withdraw 10? Man, you guys are super good at math. All right. So let's do this. Yay, all right, so we passed another test, good. Now I'm going to bring up what you asked about the withdrawal through being negative because I'm going to do this though a different way. Okay. What if we just withdraw 10? Okay. What should happen if we withdraw 10? Or let's actually change up the number. Let's make it 100. Okay. We withdraw 100, although those two are basically the same as far as the computer is concerned, as far as testing is concerned. We withdraw 100 from an account that has 0. What should we do? Okay, Arjun and Ozlam, yeah, they can be negative. Have you ever had a bank allow you? Have you ever had a bank allow you to withdraw money from an account that you didn't have money in? Ozlam, wait, you've had a bank account with like if you have 100 lira in your bank account and you ask your bank for 200 lira, they let you have it? I've never had a bank that's done that. Who do you bank with? We could, but we're doing just a simple, let's just do a simple bank here. What do you guys think is the best thing? Guarantee lets you go negative. Man, I'm banking with the wrong guys. You can go negative, I guess, if you have a loan, but we're not dealing with loan stuff here. We're just doing a simple thing, okay? Yes, they want it back with interest, exactly. And I'm not gonna, all right? So it should just reduce the account to 0, maybe. What do you guys think about we generate an exception? Okay. What do you think about that? We generate an exception if they try to take out of the account more than what's in the account. Let's do that. So let's create an exception. We'll call it insufficient funds exception. Come on. Run time. Well, it could, but we want to let them know that some error happened, because really this is an error condition, right? We're talking about we don't want to just do nothing and not tell them anything, right? Because if I went to the bank, if I went to the ATM and I asked for some money and it just returned my card and didn't give me the money, I would be kind of upset, right? So we want to make sure to tell them, hey, that's not you don't have enough money in the account for us to give you that, right? So we'll call it this. Call it double balance. That'll be our, these will be our variables. Now, all of your solutions are perfectly fine. There's nothing wrong with the ones that you have suggested. All right, there's nothing wrong with what you've suggested. I'm just saying for this example, there's a reason why I want to go this route. There's a reason why I want to do it this way. Okay, one more thing. So we're basically telling them insufficient funds, you cannot withdraw however much you're trying to from the account with a certain amount of balance. Okay. So what we'll do here, we'll add our if statement. If balance is less than amount, we want to throw a new insufficient funds exception with our balance and amount. All right. Otherwise, we want to go ahead and withdraw the money. All right. So let's see if this works. Hopefully I didn't do any major errors in this. Oh, I did. That's right. I forgot my plus sign. There we go. All right. So now let's go back and run our test. So here, what should this be? This should be 0, right? Because we should still have a balance of 0 even after this occurs. No, wait. Oh, it's already defined. Oh, there. Let's see what happens when we run this. All right, so let's see. We have a withdrawal test. All right, let's see. It failed our test case. Why is that? What happened? All right. Remember something I said towards the beginning of this, right? Was what? Was this test will pass. I will get a passed test case if this method runs to completion with no errors, with no problems. Right? But the problem is that this line generated an exception, didn't it? And if an exception is encountered, that is seen by the test runner as a failed test case. But what's the problem? This test is passed, right? We did generate the exception we wanted to generate. So we have a failed test case that shouldn't be a failed test case, right? Right, the method did not complete, but that's okay because it's not supposed to. Here's the thing. We expect an exception. Right? This is a special type of situation where we want an exception to occur. We don't want this code to run to completion. So up to this point, these other, how many did we do? 1, 2, 3, 4, 5. These 5 test cases here that we've done, we wanted them to complete with no exceptions. And if it did, then that was a passed test case. Here, we have the opposite is true. We want an exception to happen. This code should put an exception. So how can we test? How can we test if an exception occurred? Yeah, so let's see. So we want to make sure that an exception occurs here. Right? Okay. So we want to withdraw money. Want to try to withdraw money. If we get an exception, right, that is a good thing, right? Then we want to catch it. We want to do nothing. We don't want to, we don't have to process anything. Okay. What we could do is we could do this. We could make sure this happens, all right, that the balance stays 0. We didn't change the balance. Pass test case. Yeah, all right. All right. Let's make sure that if we have b dot deposit, let's test the situation where we would deposit some money. We have some money in the account. We withdraw some. Let's leave this as is. Let's leave this as 0 because I'm going to show you what will happen in this situation. Because now we should be left with the same money as before, right? Right? That was a failed test case because it should be 50. So the question is, should I give them? Should I give the 50 even though? Should I give whatever is there? That's one of those things that you'll have to ask your user, right? Ask your customer. What do they want? Do they want to give whatever money is in there? Do they want to not give anything? Okay. So let's say for the sake of argument, this is what they decide to do. All right, good. Couple more things we'll do, and then we'll end for today. Okay, what if this happens? All right, I don't have the exception. I don't have this, right? And the reason why I want to show this is because what you're going to see is that all my tests still pass. Wait, there's some of those that shouldn't have passed. Wait a second. Oh, I know why. Okay. Actually, I do know why. Okay. All my tests still pass, but I didn't have this exception happen. Should that have passed? Right, because since there was no exception that was generated here, this line was never seen, right? And so therefore, it was seen as a passed test case, but it didn't really do what it was supposed to do. Huh. So the fact that an exception should have occurred, but it did not, means that really this test was seen as it was interpreted as if it had passed, but it really should have failed, right? What can we do? All right. In testing, we would refer to this as a false positive. Okay. Meaning that we got a passed test case, but it should not have passed. The code is not working the way it's supposed to. But our test cases are passing, and that's not good because that's the kind of thing that a user will find instead of us. So what can we do in this situation? What do we want? We want, based on this code, we want this test case to fail. All right, this test case should fail right now, but it's not. So what can we do? could those are some, yeah. Okay, so let's see. You're saying a finally block, but see, as of right now, if the exception were there, so we could, what, if you do the finally and do what would you do in the finally block? Yeah, problem is that we don't want the finally block to run if this is seen. The body of the catch block expression. So you're saying like right here. Like that. Oslo, is that what you're saying? Let's see. No, see, it still passes. We want this to fail. We want this should fail right now. This should fail. How about we do this? Let's take a break. All right, so we won't be able to end too early today because I realized that there's a couple other things I want to do after the break. Let's take a break. We will still end early today though, because I don't have much more beyond this. But let's take what? Okay, so we'll take that one out and see what happens. Nope, still passes. All right, think about it over the break. In 10 minutes at 3:30, we'll come back together and we'll have an answer. Okay, because I have an answer, but I'm just trying to see if you guys are thinking through how to do this. Okay. All right. So 3:30, we'll come back and we'll finish this discussion up. All right. See you guys in 10 minutes.